Okay, thanks everyone for joining. Like, I saw there are some friends, some people I knew from a university that came in. So, as you may have probably read in the LinkedIn post description, or maybe on the mine website, like, I will talk a bit about a project I've been working on, which kind of involve like binary file parsing or file format definition in general. And just to give you like kind of the journey I went in, and like the different tool I had to check that kind of made during this project to move forward. So my journey, my interest like in a binary file parsing in general, like start with my passion for cycling. So as you may know, as a cyclist, like you tend to produce a lot of data with the help of your cycling computer or your sports smartwatches. So nowadays, like cycling, it tends to be closer and closer to motorsport than it was to a classical endurance sport like in the past. So when you start recording an activity on your smartwatch or your cycling computer, you have a lot of sensors that connect to it and start broadcasting messages to it. So the most classical and obvious one, of course, is like the GPS location, but you can also have heart rate monitoring. Your shifter can actually broadcast like the current gear you are in. You have more advanced sensor like power meter to know like the force you apply to your pedals, and even like more advanced one like to know like the aerodynamic drag of your position, like to calculate the drag of your position and then do aerodynamic calculation and comparison between position or wheels, or I don't know, frame of your bike, that type of stuff. But the idea is that when you are done doing a sport activity, you stop recording and your device will produce a fit file. So the fit file format is different from the one you may know from the Linux world. So for the rest of the presentation, just be sure that to not be confused, we won't talk about the fit file you may already know from Linux. And yeah, the idea is not that I want to force you into listening to me talking about cycling. I mean, I could do that for hours, of course, but it's just that I found that file format actually has some specificity that I found were quite interesting and quite difficult to get around sometime from some of the library we will see during this talk. And yeah, Garmin kind of went crazy with the file format definition. So in essence, like the definition of the format is kind of easy, but it's used a bit for everything inside your GPS or your cycling smartwatch. So if you plug it by USB on your computer, like I did it before, like the presentation, you will actually see that there is a lot of folder and they all have fit file in it, but they all represent different things. So the file definition is actually the same, but the content and the definition inside it is different for each type of component of that GPS. So it can be user setting, personal best, segments, activity. We will talk about segments in the next slide, so we'll see. But also like workout definition. And yeah, like the overall definition is well known, but the actual content for each specific subsection or sub definition, like it's not part of a spec provided by Garmin or anything. It's quite flexible, so you can do basically whatever you want. So my second motivation was that I wanted to provide also a tool for other cyclists to create segments. So segments are a feature of such GPS that basically allow you to do like a real life time trial on your bike. So you may know, like in racing game, like on your computer, like you have Ghost that you can actually see like the personal best of someone, and you can like follow the trajectory of someone on a computer when you are racing. Here it's basically the same thing, but on real roads and on your bicycle, of course. So when you start to get to a point somewhere, you'll get a notification on your GPS telling you, okay, you are approaching a segment. And then as you follow the road, at every moment on the road, you will have like the difference between you and the leader of that segment. And then you get a final notification when you are done saying, okay, you were 10 seconds slower, 10 seconds faster, I don't know. And yeah, so as I've said, like segments are basically fit files, just like as any activities, but the definition of it, like it's unknown. And you have to look into what's inside that fit file to know what you need to provide. So for my case, if I wanted to provide a tool that people can actually put 2 points on a map and then enter a power target to model like the time you need to, the time you need to get to for a climb based on a power target, like I didn't know like what was inside the fit file, and so I started to explore a bit more like what were inside. So for the second section, I kind of wanted like to show you like the different steps I went in. And just to start, I will give you a quick recap of the pitfall definition provided by Garmin. So in essence, like it's quite easy, as you can see here, like it's only 3 fields. So you get the header, which has the most important like information is like the size of that record array. And inside record, it's there that it starts to get a bit more difficult. So you have 2 types of record definitions. So either like field definition or data message. And the basic idea is that every data message would always refer to a previously defined like field definition. So having those type of field definition that are defined in the record, the idea is that you can actually like know how many bytes the data message will need to read, like, and it always the same thing. So you have an ID on those field definition, and the data message will always refer to that ID. And yeah, the structure will always be the same, but also like in theory, like you can overwrite like field definition to new field definition. But I don't think it happened like in practice, but those things that can be done. Also here, I kind of like abstract like the difficulty behind it, but field definition are like defined by 2 different things. So a global message number and a field definition number, and Garmin like provide like a more than 1,000 entry like dictionary based on those 2 key to define all type of definition for every type of sport or every type of user settings segments to really like be able to model a lot of those things. Also, they will always include the size and the type of that field definition. So because we will see that sometimes you also will get like unknown field that, I don't know, manufacturer add to add more information. So there are things that are possible. So you need to be able to keep like staying consistent and be able to read, even though like you don't have the proper definition. The first start when you get an unknown file format, like is a tool that you probably all used here, like the file command on your computer. And I wanted to add it here because I was quite surprised to see that file actually know about the fit file format from Garmin, and it can actually like detect like we have here an activity, so the subtype of that fit file format. But yeah, it's quite limited because if I pass like a segment to it, I will get like a -1 saying that it doesn't know like the type of that fit file. The second step, also something you probably all used, xdump, but I wanted like to provide like an alternative, like exile here is kind of a beautified xdump. Yeah, Google slide kind of messed up the alignment here with the special character, but in real life it looks way better. So yeah, just a tool I want to share that I use it quite frequently because like the colors make it quite easier to read. And already here, when we xdump like a fit file, we already see something. Like here we have the .fit written in the extension. Also here the name of the segment, so we can already like guess some of the components we will see in the header, those type of things. But yeah, that's where things start to get serious, like FQ. I don't know if you're heard of it, but it's basically also an xdump. But the thing is that FQ basically knows about the fit format you pass it as a command line argument. So it's something I should have probably used from the start, but it only started supporting like fit file since this year, February of this year. So when I started working on that project, like I don't work full time on it. I work when I have some motivation to work on it. It wasn't able to use FQ to kind of explore those fit formats, but it's a really good tool to start exploring data inside some unknown like format you want to work on. And I really recommend you to install it on your computer and start exploring different file you have you want to explore. So yeah, FQ is the JQ for binary format. So you may have used JQ as a command line tool, which is basically, let's imagine you have like a JSON file or a JSON formatted string. You pass it to JQ, and they provide like a query syntax to actually access the different component of the of that JSON object. It's kind of powerful, like the query syntax they use, and the idea is that FQ will translate that binary file to also JSON type object, and then you can use the same syntax of JQ. So it's really nice because JQ is widely used, and you can actually Google like the command when you are kind of lost, and you will always have like a Stack Overflow for your question. So you don't have to learn everything from scratch. But yeah, just to do a quick demo, like let's check a segment I downloaded like in my area, like to show you some of the components of the fit file. So yeah, the first thing you will probably do is that this is the high-level view you will get when you enter something inside FQ. So you don't get a lot of information. You get like the overall view from the top, the most important definition. But you can already, like, if you pass it to the, like, pipe it into the command in FQ, like, it will like show you all the information. But yeah, it doesn't really provide a lot of information like this. You can start to look at every record, but yeah, it's a mess. The thing you will probably want to do is that you want to look what's inside the data records object. So you can actually slice it like it's a normal array, and then you get that first data record, and you can develop to see exactly what's inside it. So it's kind of similar to the data record I showed you about in the overall like overview of the fit format, but it has a so notably it got like here you got a field definition named type, which will hold like the type of the fit file. Is it an activity? Is it a segment? Something like that. And also you can see here in the record header, you can see that ID I was talking about. So here it's ID 0 is the first field definition, so ID 0. And if you check the next record, you will see that we get a data message, and it also refers to that ID0 field definition, and so it will read like the field that got just defined here in the first record. So yeah, you can actually do a bunch of other things. A command that I found really useful with fit files is this one, which from all the data record, like it will always select the one that are defined as a definition. And yeah, you can actually print all the definition message of your segments, and you can develop it with the D command, and you can actually see each file definition. Another command that I use to filter is if I want to get all the records that are related to that to a specific field definition. So this one, which are like the different the different best time for that segment. I can use that definition that will select from the data record, we select only the one that are data messages. And from the one, I will check that only I get the field definition. Yeah, the data message that refer to that field definition number 4. So I will get this. And again, this is really specific to segments. It's different from the activities. So that's what I was mentioning when I talked about exploring the difference between activities and fit files, that activities, you actually have a lot of tools online to check the content of the records of those activities and really be able to look inside this. But segment, you don't have any tools online to explore the content of it. So that's the difference. And yeah, you can see my best time, those type of things, like the also the time over the segment of the overall best time of a person. So if I wanted to provide a tool, I would need to also provide those kind of section on my fit file that people would be able to download. And also a specific one, another specific one is that data record, like, so for each position, like latitude and longitude, there will be an entry saying, okay, the different leader, this is their time. And so your GPS will be able to process it and do the difference based on the one you want to follow. Okay. So FQ is a really nice tool to work on the command line, of course, but I wanted something that looked like a bit more like a library. So something I could use for a programming language. But again, it's really a useful tool that you should probably use to do those type of exploration. And if you want to also get your binary file as a JSON object, something that you can use externally, of course. In essence, binary file parsing is a really an easy task. It's basically only 3 things, in my opinion. So first, you have your binary blob, so that you store inside a buffer, something you can actually index. Then you have your file definition. So you will define property, so with name that you want, and to each property you will match a type to them. So basically, the type of integer, is it a signed and signed integer? What's the size of the integer? You can have like a bit more complex type, like character, array of character, things like that. And the idea is then that you have a cursor that will, for each property, the cursor will move based on the type that match that property. So here, if we have a 16-bit integer, like it will move from to position on the buffer. So something that is really easy to do in an imperative way, but if you want to kind of start automating this, you can imagine like the following parsing flowchart, as I said in the title, that you need to apply to each property. So the first thing you will do is that, okay, do I need to move the cursor to an arbitrary address? So sometimes binary file definition, they will they will have like a field in the header saying, okay, this portion of the file, let's start at that address, and then it's padded with zeros somewhere. So typically, like device tree definition, it's not sequential. Like you will have like different area in the file where things are defined, and so you need to start moving at that address first. Condition also, it's something that you saw in the fitfall definition. So is it a field definition or is it a data message? You know this by looking inside the value inside the header. So condition operator, like they will be able to define how to continue reading the file format based on a condition you pass to it. And then you start reading your basic type. So, and if you have more complex type, of course, like you will use something called a controller. So basically, if you want to create array of integer, you will need a controller that will keep reading based on the number of time you need to read that base integer. It's also something you see in the fitfall. So you need to create a record array, but the condition, the condition to keep reading that record array is that you need to match that size you find in the header of the fitfall. When you are done reading the stuff, you transform it, pretty straightforward. So you get that value, you change it to something else. So if you need to scale it, apply an offset to it, then you can validate it. It's also something you saw in the fitfall, like you have that .fit magic number in the header of the fitfall. And then in the end, you move the cursor based on the size, the amount of thing your controller has read to keep that buffer position known. And then you move to the next property and you restart the procedure. So yeah, basically you keep chaining things like this basic loop, and each property got the different those different characteristics that you need to define to it. My personal requirement for such a library were that I really wanted something that I call declarative. It may not be like declarative, strictly declarative in the sense of declarative programming, but what I mean by declarative is that I want something that is quite contained, so that is easy for the human brain to understand. So I want my file format definition to also include the different conditional. So I don't want to mix the logic of parsing with the logic of defining the basic types. I want everything to be included in the same structure. I also wanted something that would include some debugs, really similar to what FQ offers. So if by any chance, like the parser will detect that a magic number is not matching or something like that, I want the parsing library to actually help me and show me an example of what they're reading and some of the contexts they've been parsing, like what object match to what portion of the binary file. Basically, things that can help me like write a binary file definition, and you'll see it's not really present in a lot of the library. Something really important for me is that I wanted the library to be able to run in a web browser. So basically JavaScript. So I find Git pages an awesome tool for people like to access some of your tool, the thing you do basically. It's basically a free graphical interface you can provide to people, because if you start to share a graphical interface, I don't know, you've written in C, there is almost no chance people will start using it, in my opinion, because it's such annoying to run a C program, or instead of just clicking on a link and sending a file in a web browser. Also, I wanted it to be quite extensible or hackable. So the binary file format definition, they will always come up with something new. So here we saw in the fit format that they will always refer to, the data message will always refer to a previous field definition. It's something that you don't really find in the other binary file format. So, and it was quite tricky to actually parse it. An encoder will be a plus. So if you modify that object you just parsed, you want it to be possible to re-encode it into a binary file again, so that people can actually reuse it. Yeah, probably the most obvious thing, and the thing you thought when you saw that type definition, is that it really looked like a C struct. So, and yeah, that's indeed the case. So C struct are quite a declarative binary file parser out of the box. So even without applying any library or anything. But yeah, of course, you know C. You probably want to do other things, so that's where it starts to get a mess. So if I wanted like to check if this matched like the magic number, like the dot fit you saw, I will probably need to verify it somewhere here in quite an imperative way. So just check it with a condition. Also, if I want to be sure about like the endianness of my field here, I can do it directly on the struct. I mean, it's possible, probably doable now with some pragma or something, but you get the idea. Like for a basic tab, it's really nice. It works very well, but when you want to do something a bit more dynamic, you have to do a lot of the things by yourself, and it quickly starts to become a mess. So yeah, obviously. So also not made for the web. Prone to error, no debug tool included, of course, it's just C. But yeah, let's move to something else. Just to give another look at FQ and how the definition are made, like under the hood, like what's happening behind the scenes. So that's really the type of thing I wanted to avoid, because I found this to be not really good looking, in my opinion. So the thing that you have to actually control the cursor and do the checking by yourself, I don't want this to happen. I want a library to handle the cursor by themselves. So that's really what I have in mind when I think about a parsing library that is not declarative. I mean, there's nothing wrong with it, of course, but it's more about yeah, what you like to do and how you like to work than what is wrong of good, of course. But yeah, FQ, of course, is still an amazing tool. So all the debug tools that are included are very good. It's extensible because it's code, so you do whatever you want. But yeah, not declarative. It's not really a library either, and it's not made for the web. Then I found this library in Rust that I found really well written, and I really liked the idea. So you have the classic struct that you find in C, but I didn't know about that, but you can actually like add like decorator on top of the properties of your struct in Rust. And I really like the idea because here you can see that you can mix some basic tab with some more dynamic things. So this is an example I fetched from the README of the library. And here they define a vector, and they say, okay, on top of it, like they say, okay, I will need to, the length of that vector will be based on the bone pile count, which is another property that is defined on that structure. And they can also like apply like, yeah, they can also like move the cursor based on some conditions. So here, the next field, they will need to be offsetted at the position 10 of the buffer. So I really like the idea of having like more context on top of struct that can help you like they can help the parser to actually read the binary file definition. And it's something I wanted to reproduce, but of course I wanted to reproduce for something that is meant to be working or running on a web browser, so probably JavaScript, of course. But if you want to have a project that need to decode and encode binary file in Rust, that library is really good. Also, there are like other libraries that are quite similar, so I didn't do the comparison by self between all of them, but this one, like the documentation was very good. So,
Thomas?
Yes?
About the web aspects, you can compile the WebASM, right? And that cover it, or am I missing something?
Yeah, but that's not something I wanted to do. Of course, you can do probably a lot of crazy things, but people prefer to, I mean, I wanted like to have like some kind of web interface that can actually access like directly from the class I create, like the content of the feed file based on class I create. So I wanted to have everything that is quite encapsulated. And
you mean with need of compilation?
yeah, and also that you can, it's always easier to read. Like, I don't know about how to write graphical interface in library compiled from WebAssembly, but it's probably not as good as the one that already exists in JavaScript. So,
well, I haven't used WebASM myself, but as far as I understand, you can just call web functions from JavaScript. So it looks like it's with script tag. But okay, I don't know. I've never done it myself, so somebody else has any experience with it. I don't think it makes any sense to think this is.
yeah, I think some people in the call have used WebAssembly to do some stuff or to improve the speed of some of the web projects. So maybe we can have the discussion after the talk, like more in detail. But yeah, my idea is just that I prefer to have a whole project in a single language and that everything is more like documented by each other. So yeah, if you need to move, like it's a small project, if you need to move between like different languages to do to actually understand what is doing behind the scene, in my opinion, it's quite annoying. And yeah, so we'll talk maybe about this in the discussion after the talk. It can be interesting. So yeah, next library is Kaitai, is quite a different paradigm. So instead of having a library for a specific language, it's more of a domain-specific languages, and you write your definition, then you pass it to the compiler, and you can actually compile to any language you want. I mean, not any language you want, but they support many languages, of course. Then you actually use that compiled file, parse your file, and you get some type of JSON object or something more specific to your language, I don't know. And yeah, I really like that idea because if you have a domain-specific language, you are actually creating some type of standard for how to define binary file. And I find that to be really clever and really nice because you only learn a single language and then you can actually understand how every binary file are made. And yeah, it's I really like that. And that's what a Kaitai definition actually look like. I try to reproduce some type of fit file definition. So here I wrote like the arrow so that you can actually look it maybe after the conference if you want. But yeah, the main idea is that on top of it, you have a sequence section that defines like your topmost definition. And so here, like you have like the header, like it will refer to a type in another section. Also the records, it's in that type section. And all those types, they also provide that sequence section to define the different property you need to read and their base type. So here for the header, you have like the U1 saying like it's a 8-bit unsigned integer. And all the category I showed you like earlier in the flowchart, like you can also find them here. Like you have your controller, so to keep reading fit record until the data size is met. Also here, like you can repeat reading fields until we reach that number defined previously. You also have like the condition I told you about, like do I need to read a record message or a field definition? Validator to validate the magic number present in the header. And yeah, you also have a lot of debug tools that were developed around Kaitai. So here you have like a web IDE. I will show you after the presentation. And I really like that because you can just click on different section of the file and it will directly show you on the definition to what it represents. But let's go back a bit to the fit file format definition and why I didn't use Kaitai in the end. So as I said, like when you define a field definition, you will actually have to store that field definition somewhere on a global storage so that data message can actually look it up based on the ID they have to know how to read it. And that's the thing with Kaitai. I have no idea how to model this kind of global storage that I can access in the rest of my file. I mean, there's probably a way, but I didn't find it. And the only way I found is that you can actually write a bunch of code, like really custom parser for different fields to do crazy thing if it's not supported by the DSL. But then like you definitely lose the interesting part of being a DSL, because in the end you are just writing code of the parsing and not defining the structure of a binary language. So yeah, Kaitai, of course, really declarative. The way it's defined, it's really I really like it. It works on the web. You have a lot of debugs too, JSON dub, web IDE. You also have like graph.viz output. So when you write a Kaitai definition, it will create for you like a graph.viz representation of your binary file, which is really cool. And yeah, also I love the idea of providing a standard way of defining a file format. And on their website, like, they have a lot of format available for you to check and to learn more about it. But yeah, not extensible. You are constrained to the DSL definition, even though it's possible to embed external code, as I said. But then you lose all the interest of that type of thing, of course. No encoder available, only in Java when I checked. And yeah, I find the syntax sometimes a bit confusing to explore. But yeah, personal opinion. Also, I checked a bit for the presentation, the status of the project, and it looks like the pace of development has quite settled. So I don't know if it's still really well maintained or they're planning to add more feature, something to give a look. So yeah, that's the reason also I moved to writing my own library in JavaScript. I tried to look for already existing alternative, but apparently it's a subject that no one cared to do in JavaScript, and I found it, quite a pity, in my opinion, because the idea of having everything done on a web page to me is really appealing, because, as I said, I love GitHub or GitLab pages. Like, everyone can just access it on a click, and it's basically a free web interface that will run online for free forever. I mean, forever, with no maintenance from anyone. And it's really easy to do as a developer. And so the idea of having the possibility to define the format, the binary file format, being able to modify it in JavaScript directly based on the input of a graphical interface I define, and then to re-encode it and make it possible for the user to download it directly from the web page. I found it quite interesting. But yeah, not many JavaScript library do that type of stuff. Also, I wanted to mention that from the start, like an official Fitfile SDK existed, but yeah, it didn't support like encoding, and I didn't really like the way it was written, so I wanted to have something more generic, and that's the type of thing you tend to do as an engineer. You always want to reinvent the wheel and try new things from scratch when, of course, good solution already exists from the beginning. And yeah, so that's the solution I came up with. As you can see, it's really, I took really inspiration from that Rust library that I found really good. So being able to create some type of struct with decorator on top of it to add more context to the declarative part of the definition. And it's based on a TypeScript decorator. So TypeScript decorator are a feature that always evolve. I started to work with it basically around it. And yeah, immediately after it, like the old definition completely changed and I had to rewrite the project. It took me like a year to get motivation to change the project. And yeah, that's the thing with TypeScript. Like you may know it as a language that try to add types to JavaScript, but it actually has an internal agenda of pushing more feature to JavaScript and being like a laboratory for new feature before it integrates JavaScript and try new things. So yeah, decorator, they are not part of the official JavaScript spec, but you can already use it with TypeScript. And as you can already probably see, is that it tends to get quite verbose, because even though you have like that type declaration from TypeScript, like this is only known by the compiler and by, yeah, to help you write code. You don't have any type of reflection or anything else to help you directly know the subtype you need to read for the rest. So that's also one of the drawbacks of such a library, is that it can get a bit verbose. But yeah, all the feature I told you about in the previous library are present. So you can actually validate magic number, do things based on condition, etc., etc. And yeah, as I said, the lack of reflection is quite annoying, because here you have like a controller that will read 4 character, and you want the representation to be a string, but you have to do it 2 times, because yeah, you have no way to know what is the subtype here of that property. So yeah, the issue I told you about that global storage. Yeah, sorry. The global storage, we had the issue we had with Kaitai. That's the solution I came up with. I mean, it will change in the future, but is that at any time you can move out of that declarative space if needed. So here, when you are done reading a field definition, there is like a post operator that will actually allow you to do anything, and that you can actually take that field definition and put it inside a global object. And then when you are reading a data message, you can actually map the content of that global object into the subtype to keep reading it and staying consistent. But yeah, there is a way to do it in a more declarative way. So having some type of context object that will be able to define here, okay, I will need to set this key with that value, and here I need to get from the context that thing, but I still need to change a lot of things in the definition and the creation of the metadata of the object. And yeah, it's a bit difficult, but for now, for the presentation, that's what I came up with. So yeah, the pros. So of course, it's made natively to run on the web. It's really declarative, in my opinion, and make file definition easy to read. Extensible because you can move out of that declarative paradigm and start writing on your own. And it supports also encoding of objects into binary files. But yeah, I'm still working on it, so debug like it needs. Still a lot of work to be improved and look similar to what FQ offer. It can be verbal because of that lack of reflection I told you. Yeah, constructor I didn't show you, but that's not important. Sometimes it can also be verbose. If you want to pass argument to subtype, you have to declare a constructor that will do it. And yeah, it can be a bit slow for big format definition. So the fit file, like there is more than 1,000 like field definition, and I generated like class for every of them. And the first time you start the program, like it will need to generate the metadata for every of those objects before you can start parsing the file. So yeah, the first execution is a bit slow. Just the last section about encoding, like some of the issue you can find with encoding and why, like also most of the library doesn't support encoding, is that you can quickly lose information about encoding. Here, one of the features my library has is that you can actually chain different controllers. So the first controller like will get an alternate terminated string. The second one will tell you, okay, I need two null terminated string. So if you pass that binary file, like the result will be that buffer with full bar. But yeah, you lost the information about that that zero byte at the end. And it can seem quite obvious for us right now because this is an obvious example, but those type of loss of information when you are trying to combine different controller, like they happen quite a lot. And having to understand like all things are built on top of each other, like it's a really difficult subject that I still need to find a proper solution. So yeah, it's something you need to be aware if you want to re-encode file, so you can easily lose information in the process. Also, something I called dependency. So if we have a size controller, a size constraint that this buffer will be written like 3 times, like it will be written like based on the value on another property. So here, the buffer will contain only 3 elements. Then we add a new number, a new number to that buffer. We'll have a broken dependency with the size. Like it's something that won't be done automatically. Like should it be the role of the encoder to recreate that, to change that value, or is it the role of the person changing the size of the buffer to rechange the size property? Like, I don't know. It's probably, yeah, probably a bit of both, I guess. And also, like, to calculate like the size of that buffer here, it's quite easy. But if we have like the fit file definition, like the record section, like you need to calculate first the size of that record section before writing it to the header. And it's basically like you're encoding 2 times like your file, because like the record section is like the majority of your file. So it's a difficult problem in my opinion. Yeah, the last tool I want to talk to you about is bindiff. It's something I've used when I was doing encoding of fit files and comparing it to the original. So what I was doing is that I was parsing it and then immediately re-encoding it without changing anything. And it's really a good tool if you need it for those type of things, like if you want to see what's the difference between two binary files. And here I could spot like a logic issue I had in my program that actually like the altitude was not correctly encoded. So yeah, the last one. As a conclusion, so it's probably better to stick to the official SDK, but sometimes it's fun to redo things and try new things that didn't exist. Using a declarative library can come with some drawbacks, like you saw with Kaitai, like you can do whatever you want. But yeah, use Kaitai if your file definition allow it, because in my opinion, it's a really good tool, like to have really a standard way to define things. Also, use FQ if you want to explore like a file format. And yeah, always be aware that experimental features are subject to change. Like I said with types of decorator, like when the whole like definition of decorator changed and I needed to rewrite a good part of my project, like it's sometimes a bit of a problem, I guess, to use an experimental feature, but that's what you get when you try to, I don't know, have fun or be in advance. So yeah, useful links. Fosdem did a dev room about binary tools that talked a bit about some of the tools I mentioned here, like notably Kaitai. If you want to take a look, also there has been like a binary tools summit in 2022 that also had some of the tools that I share, like Kaitai or Poke or a lot of things. If you want to take a look, yeah, some of the link of the things I mentioned. I was on page with a lot of tools and also this thing, which I found quite nice, but are like they support a lot of yeah, file format, and they do this type of nice chart. So if you want to explore, get a bit more understanding about the different file formats and how they're written, it's nice. Also like the Kaitai file format showroom they have on the website. It's really nice also. Okay, thanks. Thanks for listening. It was quite lengthy, I guess. If someone wants to discuss anything or got any question, share your thought. And if you want to ask me a question in private, you can ask me on LinkedIn. So yeah, thank you. Thanks, Adrian. Yeah, Marcel is maybe you're still here. Maybe I know you work with WebAssembly. Yeah, in production. So do you want to share your thought? Maybe I don't know. Don't want to push you to say anything, but
yes. What is the question?
I don't know. Did you find it quite easy, like having to to deal with different code base. Like you have your JavaScript interface probably, and then you have like the engine of your rendering engine was written in WebAssembly, right? So like the API, is it difficult to interface the different API or?
No, in that case, it was not so, because you had an intermediary definition that linked your definition in your backend code to a definition in, that will be used in WebAssembly and then imported to TypeScript. But of course, that was already a pipeline pre-written. So I don't know the hassle to do it by yourself. I have read a bit about Rust and model languages using LLVM, which make it much more easier to transpile to WebAssembly.
And like I think your backend was written in C++. Like the matching between the object, like was it easy? Like because you probably pass some type of JSON object to your backend, like you have to use some type of specific WebAssembly object, or?
So yeah, you actually did your definition in that intermediary language where you said, this is my structure or my class, here are the different fields. And you try to keep at minimum the use of extensive C++ types. So you just stay with string, char star, integers. And yeah, you also have to make sure that you don't use 64 bits most of the time, because there were some issues, if I remember correctly, in the transpile to WebAssembly. And then, you also define then your TypeScript class that would just be the one-to-one copy of your structure defining your backend language. And then, well, if you did it correctly, then your calls and your arguments will be deserialized as expected, depending on the definition in TypeScript. Of course, if there is a mismatch, then you can have other issues where, you expect a string, but you have passed a number, and then in TypeScript, you try to interpret it as a number.
Yeah, in JavaScript, 64-bit doesn't exist as a number. I think like it's represented as a float. So I think you can actually also lose information where you're doing decoding and then re-encoding 64-bit like numbers. Can probably lose some precision. Okay, but yeah, Arnaud, I didn't want to deal with that because my project was quite simple. I was dealing with things that can be computed quite fast in JavaScript. And yeah, the use case of Marcel was, of course, a rendering engine, so something you need a bit more calculation power. But for me, I found that it was quite overkill. Yeah, IMAX, I saw that that editor. I didn't use it, but I saw it was mentioned in a lot of the conference and things like that I checked. So thank you for sharing.
I may have misunderstood things, but if I understand correctly, Gaitai uses a separate ODL basically to define the structure, while in FQ and well, in basically all the others that you mentioned, the structures are defined natively in the programming language that does the parsing, right?
Wait, let me show you. So this is the web IDE of Gaitai. So I rewrote that fit file declaration, really basic, not complete, but you can actually like click on the different section and see to what they correspond on the Gaitai object that is being produced. So here, for instance, like that magic number that is represented here. like you can directly see that object where it's stands.
Yeah, and I think you mentioned that you liked the fact that Kaitai has this definition language as a
Yeah.
YAML file, but in the end you didn't use the same approach. Then why is that?
Because I also liked the idea of the Rust library with the
Yeah.
and this is good, but
yeah.
writing an alternative to Kaitai, I mean, it's probably not as useful as having a native solution. And probably more difficult also.
Yeah.
Also, one of the pros of having it natively like here is that I can actually like write methods that directly work with the data that I just parsed. So everything is staying in the same part of the program. So method that will handle records can be defined in the record class. So that's something that I find quite, nice to deal with as a programmer. But yeah, personal opinion, I guess.
Yeah, I think indeed that having a declarative declaration, but then also a way to escape to procedural processing is very powerful and sometimes needed for some some types of parsing.
Because
I think Wireshark is actually a bit similar because, as if I remember correctly, you can also the protocols are there also defined declaratively, but you have Lua code that you can call into to do more complicated parsing.
Yeah, Wireshark could have been part of the presentation, but I mean,
it was already long enough.
It's really, yeah, really, not all the time. It's really a specific tool also. So
we have one question in the chat.
No, it's a universal library. So if you look, I got an example folder where I actually have written other examples. So device tree, for instance. So it can be written with my library. So this is the thing I was mentioning, the offset. So you got an offset defined in the header where you know where a section of the device tree will start, and then you keep reading it until like the size is met. Yeah, so work for many things. Also, bitmap. I also wrote like some type of renderer on the that work on the command line to show like the bitmap content. It's not beautiful, but you have to de-zoom a lot to see the whole picture on your terminal, but it works, and I can parse bitmap. But yeah, here the encoding, I still have to work on it. Basically, the encoding part of fitfile is really easy when the decoding is not that easy because of that global storage problem. But for the other formats, it's different. Like the encoding tend to be a bit more difficult because you can have like those part of the file that will be lost in the translation. But yeah, it was the point of the presentation was to give you quite an global overview, some of the problem you can stumble upon in the current ecosystem. I mean, probably what most people do is that they write their parser from scratch, like I showed in the C example, where they will assign a variable for each property. But it's where I started to do that, and I was like, no, I can't do that. It's so much thing to redefine. And if you have at one point you need to modify something, which won't really happen because the file definition won't change a lot. Like, it's always a pain to get back to the code because it's scattered everywhere. And I don't know. I didn't like that. And I really liked the declarative solution that were available. And I wanted to extend, I have one on my own also. Okay, I guess we can maybe stop the recording then.